If I plan it, I would say on 3rd of Jan. Uh, and we have three, and this one is like this. And we basically cover the SQL intermediate, right? And
SQL case.
SQL case. Yeah, I mean, in intermediate, we have a couple of items. So one is aggregations. I think we will be revising also. Just we will taking a look. I think in intermediate also we covered. I think all the intermediate or like only some of the. I think
I
only
think
some of.
only some
Okay,
of them.
okay. Aggregation we covered. Then let's open the intermediate. Yeah, I think we want distinct. So it look like aggregations are like count. Group by having case. Yeah, case also will be some count, min, max, average. Then we have cases. Okay, okay, correct. So we were distinct. Okay. Let's start with that today. And distinct. Okay. Just give me a minute.
Anyone is joining with the name of iPhone 13?
No.
No? Okay, let me check with Dave. Okay, Dave. Express. Hello.
Yeah, Ty, just give me a moment.
Okay.
Hey, why am I unable to hear the voice?
Even I am
Hey,
unable.
Kyle.
Think he has stopped right now.
Oh, okay. Yeah. So, Havan and Ravi, did you connect with laptop or mobile?
Laptop.
Laptop.
Ravi, what about? Okay, sure. Yeah, nice.
Okay, sorry. So let's start. Something came up actually urgent. Okay, so joins. Okay, so okay, case statements we covered. We explained that like we can create another kind of column, and this column what we are doing is I think this one is a complex one. So let's go to a simpler one. Pawan, did we cover case statement or we need to start that?
We have covered case, but can you explain again that?
Okay.
Yesterday you have covered this. Yeah.
Okay. Basically, what we are doing is here we are selecting year column and we are trying to create another column. So just a moment. Yeah. So here, what case does? Case actually help us to create some columns based on other columns using conditional logic. So what we are doing, we are saying, I want to create this kind of column, and this is the format of case. So if I just comment it out, you can see that select player name, year from this table, right? These two columns. But with case, what I'm doing, I'm trying to create a new column, and in the format looks like this. So we say case and the condition. When the column is SR, then I want my value as yes, otherwise null. and we say after all the conditions we add at the last case and that and as the column name. So we are saying this is my condition and I want to end as this particular name of the column. So is a senior. So here you can see that whenever we have ESR, there you can see yes, otherwise null. So this is how case works. And similarly here, we are simply replacing null to with no. So what we are saying is whenever the year is SR, yes, otherwise no. So you can see that or no is coming then. And then here what we are doing, we are again putting some condition. So whenever we have, like, for example, here we just have two condition. I mean, obviously one condition, but otherwise we say else, like what we will do in remaining cases. So else no. Here we are saying three conditions and the fourth one will go automatically under the remaining cases will go in this label. So here we are saying whenever the weight is more than this, then label it this, and we are naming our column weight group. So you can see that labels are automatically coming as per the weight. So for example, 190. So we label as more than 175, but less than 200. And you can see the label here. But you can see one thing here that we are taking some capabilities of SQL to automatically infer. So what happens? It actually goes in this order. So whenever we get like the records where the weight is more than 250, those records are labeled as this. Now the remaining records, the if condition, the case condition will only be applied on the remaining cases. So you can see that because the rows or the records where the weight is more than 200, those will also come, right? But because that is automatically handled, therefore we on the remaining records this particular label is done. But we are saying this is not a best practice. So the best practice is the answer will be same in this also, but it will increase our lines, like 3 additional lines we are adding in our query length. But it is a best practice that also mention the upper limit. So we are saying when the weight is more than 250, then this label, and when the weight is more than 200 but less than equal to 250, then this label. So that way we are explicitly mentioning all our condition, like okay, this particular range, this particular range. So that way it is like a best practice, consider this, but answer will be same in both the cases. Then we have another one. So we are saying when year is FR and position is this. So this also we can do. We can take multiple columns also, and or condition we can apply. So we are saying when year is FR and position is WR, only in that case I want this label for my column, otherwise null. So here this condition is not applied, only applied for this particular record. And we have to notice like and condition, because what will happen when year is FR but this condition is not matching. So we have to match both the condition, only then the label will be this, and the name of the column is sample case statement, like this. So here what we are doing, we are again adding some aggregations in our column. So we are saying create a case and then also the count. And then when we group by, we are actually passing the same condition. So here instead of that also, we can simply use alias. But here what we are trying to show is that how to use the aggregation. So internally, when we use alias group by this, we are obviously first creating this kind of column. So that way case statement we can use, because it's a finally what is the output of case is a column. So that column is something, as you, if you remember in group by, we noticed that when we group by something, we apply our condition aggregation logic, sum, count, or max. The other column should also come in the group by logic. So that is what is happening here. But this column doesn't exist, we are creating via case statement. So therefore that also we can mention here. But simple alias also work, like because this and this is same. So whatever we are doing, we are simply creating this logic in the group by also instead of alias, both are same. Then here we are okay, select count. This is not case one. Here we are saying case 1, 2, 3, 4 condition, otherwise else in this case this, and naming it like this. And you can see now this time we are using alias, and also we are again using the, after that we, you know that we can also use index. So we are saying one means the first one here, which is obviously this particular column that we're creating. So grouping by that year group. So you can say by year group, we have 5 group we created, and each one we are getting a count, right? So this is what is we are doing here. So we can easily see that the no year data we have one record, and GR we have these records, SO we have these records. So this is very interesting one, this piece. Then here we are just trying to create a pivot table. Like, okay, we every record I want in a separate column. So we can simply append like this: one condition, two condition, three and four. Each one we can say this, like we are naming it FR count, SO count, GR count, and all that count. And here we are saying count and wrapping it like this. So what is happening inside the case statement? We are creating a column like this, and on top of this we are using some aggregation function. So this is exactly same like we did in our min max case here. So in our min max also we see that we pass to min and max, it is coming in two different records. Similarly, what we are doing here, we're creating four columns, but those columns are like count aggregations. Yeah, this one. So count aggregations we are doing, this one count, and inside the count we are creating this particular new column FR count, but based on the other column. So it's like not a simple count but a cased count. So this way we can create this kind of table. Now this is like distinct, where we need to start today. So we are saying distinct actually filters out the duplicates and only show the unique. So here we are saying select distinct month. So distinct means if we say select month, then all the records will come. But if we filter out with distinct, only the unique records will come. So you can see that uniques are 1 to 12 months number. And then here also we are applying distinct on year and then taking the month. So then you can see that the distinct records are coming and the corresponding month records of that. So distinct is like this, and inside count also you can use distinct. So whatever is happening, like first we are getting the month list and then we are counting that. So that way we can also check how many total number of unique values are there. So this will give us the list of unique values, and we can also use count there. So the business logic will be, if you for a particular column, if you need to know how many unique values are there, you can simply run this and changing the month name here. So that will give you the total number of unique values. Then comes another category called joins, and these are also very important, like joins. So let's understand with some graphics first. In my notes, I added something. Yeah, this one, let's understand with some logic. Yeah. So it's like this is a site called, this is a joins.spathon.com, and it actually helps us to understand some basic joins. So if you are coming from mathematical background, in mathematics, there is a concept of set. So that Venn diagrams and all will come. So in Venn diagram, we generally understand this concept. The same concept here is like what we do in joins. So basically, you can consider this ring as a data set or table in SQL. So we have one table, another table, and if you want to merge or combine the two tables together, so what will happen? So here we are saying the first join we call inner join or simply join. So what inner join does? Inner join select the common records only. So let's say if on your left side on the table 1 you have 10 records, in table 2 you have 10 records. So if you merge these two together, we need to first of all select a merging condition, like on which column you want to merge. You can select one column or multiple column, and once you decide on which column you want to merge, which are common in both the tables, then we need to select which type of join you want to do. For example, if we say inner join, then only the records which are common records, how we are identifying based on the key, the common key that we chose. The common key which are they are available in both the data set, only those records will be combined. So let's understand with example. So here on our left side, we have users table. On our right side, we have likes table. So we need to merge the two. We need to see what users and are and what they like. So we are getting the name and the like. So for example, if this is my table and this is my another table, I do the left inner join. Inner join is this is the output of inner join. So if we interpret it, first of all, let's say what is a common key. So in our query, we can notice that something on this side. We'll also understand the pattern there, like how to use the common key. But we use this kind of thing on and the like left and right. So we are saying ID user stable ID and like stable user ID. So it's mean this and this. So now when we inner join, what will happen? Only the keys which are common. So let's understand what are the common keys. One is available here, one is also available here. Then two is available here, but not here. So two will not come in inner join. One will come, three will come, four will come. And therefore in this site also, they actually like crossed it out to understand better, like which record will not come. So you can see that 1, 3, and 4 will come. From the right side, also 3, 1, 4, these keys are common, but 6 is not common. 6 is available in right, but not on the left side. So that will not come. So only the common keys you identified are 1, 3, 4, and yeah, only 1, 3, 4. So those will come here. So you can see that my area, which is 3, is mapped to stars because of the common key 3 and 3, right? We merged the two based on this key. And then we have Patrick, because there are two records, so each record will come in a new row. Patrick likes climbing, Patrick also likes code. And then we have Darwin likes apples, because here we in our likes table we know that user ID 4 likes apple, and here we are getting the name of the user. So we are saying Darwin, which is ID 4, likes apple, because in this table we got that information. Then if we switch it to some other type of join, so let's see what will happen. If we switch it to left join, so then you can see the output is changing. So what is happening? All the records, as you can see in the highlight also. So this highlight, the filled column actually tells us what is the final output when we join. So you can see that all the full circle is like filled on the left side. So that means all the records from the left will come, and records means based on the keys. So all the keys from the left will come, but on the common ones only from the right will come. So that means 1, 2, 3, 4, 5, those will come. But here only the ones which are available on the left will come. Just like therefore we call it left join. We are prioritizing the left table compared to right. We definitely need all the records from the left, but only the records which are matching from the right. So therefore you can see that Patrick again, because there are two records of that. Then Albert, and Albert is something which is not available. We don't have information, but still it is coming because of this record. Now Albert is coming, but we put null because the Albert likes information is not available. Similarly for Elizabeth. So this is how left works, and the right is opposite. So all the columns, all the keys from the right will come, but only the common ones from the left will come. So you can see that 1, 3, 4 will come, and then 2 and 5. So that will be ignored. You can see that this is like crossed out 2 and 5 because of that, because all the records definitely should come here, and only the common ones which are like we can match, those are coming. And outer join is like we combine both, like all the keys from the left and all the keys from the right will come. So if we check Patrick, we have two records, we joined them. Then Albert coming from the left, so no information here. Same for Elizabeth and rugby. So rugby is available here. The user ID 6 likes rugby, but we do not know from this table who the user ID 6 is, right? So therefore, this kind of table will come out. I hope it makes sense now, like what joins do. So if we switch it back to our code, yeah. So yeah, let's understand now. So what we are doing in this example, we are saying select this particular conference, and also we are taking some kind of aggregation. we are trying to find the average weight of the player. Here, these two columns we are selecting, and then the group by format. When we need to group by, we need to pass the non-aggregated column, which is like conference here. So we are grouping by conference, and each conference we are trying to say what is the average weight of the player in that conference. And this is the actual thing. Like what we are doing here is we are saying from this table, and we are aliasing it as players, simply players. We can also go with without alias. In that case, we need to mention this long table name every time in all the places we are using that table. So we simply call it. You can also say PL or P. That will also be fine. Any alias will work. So we are saying players table, then teams table, and the condition. We are saying from this table join. So whenever we do not mention which type of join, inner, outer, left, right, by default it is inner join. So we are saying from this table inner join this table and the condition. So from the teams table, we are joining on school name and same as players. On the players table also there is a column called school name, and that is like on which key we are joining. So after joining, we are also like ordering by the average weight. So that way, this is out. So we have conference and the average weight of the player in that conference. So this is like how we merge the information from multiple tables. And then we have inner join again. So here we are seeing all the players, all the columns from the players table and all the columns from the teams table. And then we are joining. So this is like the joint table look. All the records are coming then. Then here we can again say there is no specification of the type of join. So it is inner join. We are saying school name and also this school name, and we are naming it as team.school name as team school name, players.school name as player school name, and then the join condition. So you can see also like this. Then we have a left join now this time. So you can see that I think this is a simple join, and then same condition we are saying how it will look in the left join. So this is the inner join case. Inner join we are saying select these four columns from this table and inner join this table on this particular condition. Now when we apply left join, so all the records from the left table will come, and left table how we decide based on the order. So in which order we mention here, that becomes our left. So this is the left table, companies, and the right table is acquisitions, and the condition is same. So these four columns are now coming here. Now similarly right join, we say left join like this, and right join we simply change it to right like this. So that way all the information from the right will come, and only the keys which are available like permalink. If permalink is available on the left, but that permalink is not available on the right, so from the left those records will not come, because those permalink we are saying ignore them. We are focusing on the right side, which is like company's table this time. Now here you can now I think you can easily interpret like what we're doing. We are selecting again four columns from this table, left joining with this table on this condition, and then we are ordering by. Ordering by one means this particular column order. It's like 1 2 3 4. We are ordering by permalink. Then here we are again saying select these four columns from this particular table, left join this table on this, and also we are applying conditions. So we are saying left join with this table on this one, and where the company permalink from this one is not 1000 memories, this particular label. So we are saying join, but make sure that from this table this particular set of records filtered out. So we are dropping the records first, and then we are left joining. So this is how we can do the two things at the same time. Like instead of first dropping the columns based on the condition and then joining, you can simply mention your condition here as a list. Then again we are saying select from here, and we are saying two condition. We are saying left join this table where this particular condition is there, or this is null. So these two conditions we are passing using where this time. And then we are saying union. Union means Like for example, here I tried to show like this. So what I'm doing in union, there is a keyword called union, and that actually helps us to stack the data set together. That generally works when we have like exactly same tables, but in a two different tables, and we want to stack them together into a single table. So union helps there. So we say select all the columns from this table and the condition, where condition, and then we are saying, so this is like a one record, like first record, and then we say union the second record. So when we run it, like two records like combine on top of each other. So it's like horizontal stacking we are doing. And then here we are saying select and then these three are like our columns and the aggregation. And then you can see in group by also we are simply passing 1 2 3, all these three want to group by. So each of the combination out of these three will be a group, and in that group we are counting how many investor permalink are there. And then we are joining from the two tables and also passing the condition. We are saying left join this on this condition, and the funded year is more than the founded year plus 5. So all the records where the funded year is more than 5 years ahead of the founded year. So that means from business side, like company is at least 5 years old at which it is funded. So that means the records will come, and you can also see the advantage of using index now. So we need to mention like this kind of columns in here in group by. Instead of that, we simply say 1 2 3, so that 1 2 3 automatically consider these three columns. So you can see that these particular groupings are coming, and these are the records. So when we select these records, only seven records are there in this particular group. So that way this table is built. Then again we are applying the same thing, and you're saying count from here, left join on this when condition is this, and group by 1 2 3. So now here also we are doing the same thing on this table and this condition. Then sometimes we need to actually we can, I mean, it is possible to join the table with itself, because you can consider it like you need two different records and want to merge something out of that. So here we try to simulate that kind of situation, and that is called self join. So just like left, right, inner, outer, there is a concept of self join. Self join simply require only one table, and that table we can join with itself based on some condition. So here we are saying that select a company name which are distinct, and from this table Japan investment, and that table is coming from where, you can see that from investment part 1 and joining investment part 1. So that means the same table, and this table we are aliasing as Japan investment, and the right side table we are saying Britain investment. So these are like two different tables we are creating, which are internally the same source table. So once we inner join them, and here we are also using the keyword distinct, and we are saying select only the company which are distinct, and then after joining, and these are the condition on which we want to filter out the records. We are saying on this, and the investor country code is GPR, and the funded date, the same logic, like where the Britain records funded at is more than the Japan investment funded at. So it's look like we are trying to simulate this kind of business requirement. So they wanted to identify companies that received investment from Great Britain following investment from Japan. So they are saying they want to find the companies where they first received the investment from Britain, and then following investment from Japan. So they are saying this kind of logic they are trying to build, where the funny data is more than the funny data at this one. So that kind of information we are trying to extract, and then we are saying where condition. So where country code is Japan. So that way this same table we are using, and these are the results. So cell join is a bit complex, and it is actually comes in a kind of advanced way, but left, right, and inner, outer, those are like pretty standard. So make sure you practice them and then jump to cell join and try to like join the table with itself. And that way actually is not that way, like, but you can imagine it like a two different tables then which you are trying to like merge in some way. So this comes with our intermediate session. All this logic like joins and
Can you explain self-join again?
self join. Yeah, self join is what we do. We are actually, for example, in this particular case, what we are doing, our requirement is that, and I mean, in theory, we are saying sometimes it can be useful to join the table to itself. Let's see. Let's say you wanted to identify companies that received investment from the Britain following investment from Japan, right? So that is our case. Like we want to identify companies where they received the investment from two different countries, but in order. So we have information about time. So that time information is coming here, and we are saying we are putting condition here. So we are saying investor country code in this case one, and in another table, when we have final records, we are applying a where condition. We are saying on the final record, select only the records where this particular table dot country code is Japan. So that way, only the records where Japan investment table have Japan countries, and Great Britain table has this particular record. So we first we it's like filtering out the separate records. So from the left, let's say we have two countries in our Britain and Japan. So from the left table, we are selecting only the records where the country code is Britain. Let's say 5 records are Britain. So therefore, after applying this and condition here and the where condition here, we have five records now. And then we are trying to say that another condition after you filter out the records is where the this particular timeline is more than the another table and that particular timeline. So only those records will be joined together. Does that make sense?
A little bit.
Okay. So I mean, I will share this code to you, and also, if you want, you can run it. And for running, actually, you need to create a server and make sure that you can also take help, like if you need to like set up your server and all that stuff, so that you can practice all the queries that we are running. But otherwise, I would suggest there are like a lot of databases and queries you can practice on lead code and status scratch, the two sites we discussed earlier, right? So
Yeah.
make sure to practice on those sites. That will be super helpful.
Which
Like
one?
initially,
Lead code and another
Strata
website.
Scratch. Strata Scratch. So
Okay.
it's like I think I might have mentioned somewhere. Okay. Okay, so let me mention here. So we are saying this one, Strata Scratch. These two actually are good for Python and SQL, both. Okay, so let's go to some advanced stuff. Advanced, I would suggest you can ignore also because it will just increase the complexity. So intermediate is something which comes relevant, but advanced actually is also sometimes we can skip if we are beginners. So do you want to continue or want to skip?
Yeah, continue because I'm familiar with all the basics and intermediate. So
Okay.
intermediate
So
I know to some extent. Yeah.
okay. So in advance, like the one is the date. So for example, you can have some kind of dates also that you need to manage. So here what we are doing is we are you can see that we can subtract the dates from each other. So there is actually a function that we typically use, date call, and that function is something we use. But here also, because when we create the table, we have to mention the schema. So if you mention the schema as date or date time, Therefore, the SQL automatically knows that this particular column is a date time column. So you can see that whenever the null occurs, you can see net instead of null. They represent this with net. Net means not a time. So that way, it's actually like a null presentation. That time is not available here. And when we are trying to subtract from one, you can see that acquired at clean, this one, and found at clean. So we are like trying to subtract the timelines. So here unit I'm not sure like which unit it is in, I need to check, but what is happening, it is like subtracting the times from each other. So here for example we can see that it's almost 1 year 4 months, right? And here it is 2 years 3 months. So it's like, therefore year by year you can see double the numbers are there, but some unit is there maybe in microseconds or something on that side. And but interesting thing is like this. So whenever we have null, we are not SQL is trying to actually using some default values, which is actually something on like 1980 or something. So that is like a standard way where they use that as a base. So that base, when we subtract that base from 2010 year, so we are getting this long string, and you can see that almost they are same, this one and this one, because date is same, but here it's like changing a bit. So date is like 4 years ago. So it is a number also bit changing. So it looks like what this is doing, it is exactly filtering out like 2006 year, then 06 this one, and 01 this. So it's like simply I think it is not subtracting from the base this one, but they are simply adding some more granular numbers after the base, right? Something on that side, because you can see that year is coming here and also the months are coming and the date is coming, but here we have some more zeros, maybe for I think 6 zeros or 5 zeros, 6 zeros for some microseconds or something on that side. But yeah, I mean overall thing is like we can work with date times also in SQL, and make sure to like whenever you practice some lead code questions on dates, and make a special focus on that, because in interviews whatever we are learning in advanced, that concept also companies actually focus. So you will see some date times concept there also in interviews, especially they ask you I mean they will ask you a couple of things from SQL side, but date is also their favorite, like they focus on dates concept. So whenever you come across any date concept, put some special focus on that, because once we pass basics and intermediate, only this one is where we can compete, right? So date is one where we need to compete on. Then in date also you will find this function often, which is called now. So now actually get us the latest time, like what is the current time of the system on which you are working on. So that system is like comes here as date time, and that also we're trying to subtract the founded clean. So you can, that some values are coming, so you can see that whenever we ran it, that because of net they identified the pattern that the first four are like year. So it looks like 31st December is the last one when we ran it, so that it looks like subtraction, and this particular year is coming, so it is on that side. So
So we
now is
can also
also
use system date, right? Instead of now. So sys date.
state in SQL.
Yeah.
Okay, yeah, we can use that maybe.
So can you tell me the
So
founded
now
time ago?
and
What is that number?
uh, which one? This
Founded time
number?
ago. Yeah.
Oh yeah,
That is
this
it different.
number, the unit actually not sure, but for example, whenever we subtract, we are getting some kind of records here. Maybe
Okay,
it is
okay.
a Unix time format or something on that side. I need to check on that.
Yeah.
So this one is date. Make sure focus on dates a lot whenever you come across. Another is strings. String is also like where in nowadays, because we get a lot of text information, so we try to use SQL as much as we can to filter out the records directly there. So there are a couple of keywords actually in the strings. So first of all, we have left, right. So for example, here you can see that we are selecting this column, and third column is some kind of transformation on date. We are saying from the date, pick the from the left side 10 characters. So you can see that 4, 5, 6, 7, 8, 9, 10. So
There
this one
is
we
a
are picking.
breakage in your voice. Hello.
Yeah. Hello.
Can you explain from left? There is a breakage in your voice.
Oh, yeah. So left actually like is a character where we decide from which column and how many characters you want from the left. So we are saying 10 characters from this column will become this kind of values in this column. So you are saying that 10 characters from left means these 10.
4, 5, 6, 7, 8, 9, 10. Okay.
Yeah, so that is something which we do left, then same is right. So we say how many characters from the right we need. So we are saying 8 characters from the right. So you can see that they are picking 8 characters now.
Okay.
And then we have like we can also this the advantage of this kind of formulation. This is same as passing the number like this, but what will happen? It actually makes us uh, like we can pass any length of string. For example, here, if you use this kind of setting, we need to pass some fixed length so that we can pick from left to right. But here, only from the left, we have to mention. So what we are doing from the left, we are picking 10 characters, but from the right, we are saying that based on the length of date minus 11. 11 means because we have space also after this. We are saying whatever the character length is of this date, which let's say is 20 here. Imagine like it's a 20 in the first one. So what will happen? We are saying 20 minus 11, which is 9, right? So we are taking 9 characters from the right. So that will be like everything up to initial 11. So that will automatically calculate the right number for us. So that way we can easily break the variable length of values also. So in one case you have 20. In another case, let's say we have 30 character string. So you are saying 11 from the 11 from the left, and whatever is the remaining, just pick it in different columns. So that we can pick dynamic length of a string also. You can split. Now this one is another keyword called trim. So trim simply like remove whatever signs you pass here, it removes those signs. So trim means removal or cleaning. So here we are saying from the both side, left and right, remove this particular character. So and you can see that when we this is output, we are saying this one is not available now. There's a another form of cleaning. You can see that it looks actually clean now compared to this. So trim is another keyword. Then we have position. Sometimes we need this also. So here we are saying that this particular character in this column, whatever position this particular character is coming, just get that position for me. Select position means the index. So we are saying in the first case it's like occurring at 8th position. In the second case it is occurring at the second position. In the third case it is not occurring, so therefore 0. Then that way a 0 means not occurring, otherwise it will give you some number, or which like it is first occurring. Then we have another one is substring. So here we can take a slice of a given string. Here we are saying from this particular column, start from 9 and pick a slice of only 2 characters. So we are
Can
saying,
you show me the position code? Yeah, this one. Can you explain this one?
so position means like we want to know for the given input at which time A is occurring in this particular column. So that will give us the position of that particular character. So we are saying A is occurring at the 8th position here. So we get 8 here, then 2, so 2 here.
Shows from left direction, right?
Yeah, from the left.
Okay.
Then we have substring. Substring means like a slice of a string. So if we have like we have starting from the 9, we are taking a slice of 2 characters. So therefore, you can see that that means like this 31. So you can see that string is coming as a column that you are mentioning. Then another is concat. So we are saying this particular setting, and then we are concatenating. So in concat, you can pass like whatever you want to concat. So in this case, what we are doing, we are saying day of the week and then comma space and this particular thing. So therefore, you can see the output here like this. So which is like day, then comma space and this. So concat is another one. Then we upper lower. So it just simply uppercase everything or lowercase everything. Then we have another one is extract, which comes I think from the date side. So MySQL will automatically understand the date time side. So we can also apply this function on date time object. So we can say extract year, month, day, hour, minute, second. We can extract all those in a separate columns also. So that also date time feature comes in Excel. SQL. And then because this is also like sometimes you need to extract only particular thing. So this is how we extract hour, minute, or on any time range. Then another one is colis. So colis actually is like a missing value fill. So whenever we have missing value or null, you can say that you want to fill the no description label in that case. So when and this is like colis we use to fill out the missing values. So this is like some like strings case where we work with the strings. Then another class which comes is subqueries. In subquery, what we do, we basically write a query inside a query. So we are saying, first of all, we focus on the inside query. Then once we run that query, is a table now for us, which you can easily refer. So what we are doing in this particular setting is we are saying select all the columns from this table and the filter we are applying. So once we have this table, we are naming our table as sub. And then once we have this table, we are simply saying select all the columns from the table and from this table name, which we are doing, where the condition. So whenever you are writing the query, first focus on the inside queries and then forget about them. Focus on the inside queries, then consider them as tables. You can imagine that this particular thing is existing in the database. That way it will make it easier to understand. So once you write your subquery, the only difference here is this is not existing. You are applying some logic on the fly. That logic are applying, but you are treating that as table then. So that way you are selecting all the columns from the table where this condition is matching. Does that make sense in the queries?
Yeah, we can simply write this query also, right, instead of subquery, directly selecting.
Directly selecting what?
Like instead of using sub, we can write the subcode, subquery code, and we can write where condition. That is enough, right?
I mean, you are saying running it as a separate code.
I mean, where like what I'm saying is like instead of means in this scenario, we can use the direct code also, right? Instead of subquery, like selecting the subquery and using the where condition as where is equal to like where date of equal to Friday and resolution is equal to none, comma limit 10. Same
End
output
condition
will
you are
come,
saying,
right?
end condition you can apply.
Yeah, yeah.
Yeah, end condition we can apply here. So we can say where day of week Friday and resolution is none. So those records will be same. Then here we are seeing yeah, here we again are doing this. So what we are doing, first of all, we need some table, and let's imagine we have some table in database. So what we are trying to do, we are saying select this particular thing. We are from the date, we are selecting only the left two, and then another is day of week, and that third is average. What we are doing is we are trying to group by one and two and order by one and two. One and two means this one, and this one. And the third one, which is remaining, is we are taking average. So average incident per clean month and day of week categories. And this particular information we are building. So we are saying, first of all, we need to build this particular table logic. So we are saying in this table that this particular grouping by 1 and 2 day of week and date we are doing, and we are taking the count. So we are taking the total number of incidents that is happening on a day of the week and also the date. So these two are categories that we are building group on, and in each group we are taking the counts of incident. So once we this particular setting, this particular table is ready, then we are building this particular outer layer on this particular table sub. But here the logic is it will be very complex if you try to like build it in a single way, like from the single table, because it could be also impossible in some cases. So subqueries not only like help in writing easier code, but also make our code easy to understand, easy to like interpret also, and also optimized, because sometimes when you use subqueries your code also gets optimized. So it is recommended like as much as you can use subqueries, try to use them so that it is very easy to like work with SQL queries. So here you can see we are doing two kind of grouping. So first of all, we build this kind of table, and then we build our outer table based on the results that we got from this table. You can see the average incident we are getting from the particular label, day of week, and also the clean months. This is the logic we picked from the left of two. Then another, I think, same one we are doing now from different sites. So we are saying select all the columns from this table where, so what is the logic behind subqueries? Subqueries not only we can apply during from, which we consider as table, but also in where. So here we are saying select all the columns from this table where the date is this. So you can also use this like a filter, right, in where. So remember this, like not only during the from we can use subquery, but also as a filter. So here we are saying where your date is a minimum date. So this is a logic where date is what, date is like this, select the minimum date from this. So this will give us a simple value, right? This value was something that we didn't know, and that therefore we need to like calculate that value first inside a subquery, and that will be like our value. So whenever we do not know the actual value which we need, we simply can create a subquery out of it. So SQL will first create the subquery, get a value here, and that value will be minimum date, so that we can filter on that, right? Okay, so we will stop here. We will continue from there. I think some more subqueries will come, and after that, some more concept like window function is available. So window function will do. Make sure to parallelly start the practice of lead code also, right? That will be helpful.
Okay.
So SQL and Python are like two essential languages that we need to cover. And then if you're comfortable with these two, only then like you can move to PySpark and Scala. Otherwise, I would recommend like focus on this one, because there is no advantage of like doing all full languages at the same time. So if you have good command on Python SQL, then we can also move to PySpark Scala. So when we complete SQL, let me know like if you want to continue on PySpark and Scala also, we'll cover that. And I mean that will be also good because you can anyway watch recordings later also. So we'll also, that will be helpful. Okay then. See you tomorrow then. Thank you all of you. Bye.
Yeah. Bye.
Thank you.